Between 2019 and 2021, global media outlets were flooded with headlines that sounded like a direct page out of a science fiction novel. The world's first luxury space hotel would open its airlocks to tourists by 2027. Startups like Orbital Assembly Corporation, hyping their massive Voyager and Pioneer stations, alongside early pioneers like Bigelow Aerospace and Galactic Suite, released breathtaking 3D renders that captured the world's imagination. They promised massive rotating wheels in low Earth orbit, panoramic suites overlooking the curvature of the planet, fine dining restaurants operating in partial gravity, and spacewalks for any ultra-wealthy traveler willing to pay a few $1,000,000 for a weekend getaway. Venture capitalists leaned in, and technology enthusiasts began packing their bags. But here we are, in 2026. Instead of grand ribbon-cutting ceremonies on orbit, the industry has delivered a trail of corporate liquidations, quiet rebranding pivots, and a total inventory of 0 commercial hotel modules operating in space. Bigelow Aerospace laid off its entire workforce and shuttered its doors after burning hundreds of millions of dollars, while remaining startups quietly pushed their launch timelines into the indefinite future. How did a multi-billion-dollar vision backed by massive media hype collapse into another technological mirage? The answer is simple. Marketers sold the public a high-tech fairy tale while completely ignoring the brutal, unyielding laws of physics, orbital mechanics, and basic unit economics. The physics bottleneck: mass, capex, and orbital mechanics. The foundational lie of the commercial space hotel lies in its sheer physical scale. To construct a rotating wheel station like Voyager, designed to accommodate 400 guests and crew, you must launch a minimum of 2,500 to 3,000 metric tons of structural materials, shielding, and life support hardware into low Earth orbit. To put that into perspective, the International Space Station, ISS, weighs roughly 450 tons, took over 15 years and more than 30 spaceflights to assemble, and cost an estimated $150 billion across 15 participating nations. Even if we project an aggressive reduction in payload shipping cost using next-generation heavy lift vehicles like SpaceX's Starship, assuming an optimistic $500 per kilogram, the freight bill alone just to lift raw mass into orbit exceeds $1.5 billion. However, raw mass is only a small fraction of the total balance sheet. Space-grade, hardware, human-rated environmental systems, and robotic orbital assembly cost between $20,000 and $50,000 per kilogram to manufacture and deploy. That places the true capital expenditure, CapEx, of a 400-guest station well north of $45 billion. To service the debt and depreciation on a $45 billion asset, a space hotel would need to sell every single room for $10 million to $15 million per week at 100% capacity, 365 days a year. The global pool of ultra-high net worth individuals willing and physically capable of making that journey simply does not exist. Furthermore, the physics of artificial gravity introduce a mechanical nightmare. To generate partial gravity, roughly 1/6 of Earth's gravity, similar to the Moon, through centrifugal force, a station with a 100-meter radius must spin at approximately 3.8 revolutions per minute. At that rotational speed, human guests experience severe Coriolis acceleration. Every time a guest turns their head or stands up rapidly, their inner ear experiences violent disorientation, motion sickness, and continuous nausea. To eliminate Coriolis sickness, the station's radius must exceed 200 to 250 meters, ballooning the structural mass and cost exponentially. Moreover, docking a supply spacecraft like SpaceX's Crew Dragon or Boeing's Starliner to a station traveling at 28,000 kilometers per hour while spinning requires a non-rotating, despun docking hub at the exact central axis of rotation. A single mechanical seizure, alignment error, or seal degradation in that rotating bearing joint would instantly shear off the docking mechanism, triggering catastrophic depressurization. The ECLSS trap: maintenance, radiation, and emergency evacuation. In a luxury hotel on Earth, the worst-case scenario for a guest is a bad review on TripAdvisor. In low Earth orbit, the worst-case scenario is explosive depressurization, radiation sickness, or asphyxiation. On the ISS, highly trained astronauts with advanced engineering degrees spend nearly 50% of their operational working hours performing routine maintenance, repairing urine recycling units, replacing carbon dioxide scrubbers, patching micrometeoroid hull degradation, and recalibrating thermal regulation radiators. In a commercial resort, guests pay for service, not plumbing duty. This creates an impossible operational dilemma. A hotel operator must either maintain a massive permanent staff of elite aerospace engineers whose multi-million-dollar astronaut transit costs destroy any remaining profit margins, or rely entirely on fully automated environmental control and life support systems, ECLSS. Current automated life support technology is notoriously complex and prone to failure, requiring constant hands-on human intervention. Compounding this is the radiation problem. Outside Earth's protective atmosphere, orbital tourists are continuously exposed to galactic cosmic rays and solar particle events. Shielding a station against a major coronal mass ejection requires thick water jackets or heavy shielding barriers, adding thousands of additional tons to the launch manifest. Without heavy shielding, a single solar storm could expose guests to dangerous radiation doses. From a regulatory and safety standpoint, the business model completely breaks down on emergency evacuation. International space safety protocols mandate that every individual on orbit must have an instantly accessible, dedicated emergency return craft. For a 100-guest facility, that requires 4 to 6 commercial crew capsules continuously docked at the station. Keeping $500 million worth of spacecraft sitting idle at orbital berths, just in case, generates burn rates that no private business model can absorb. Macroeconomic sobriety, the death of ZIRP vaporware. The saga of space hotel startups mirrors the exact collapse witnessed with Hyperloop One, Sono Motors, and Lilium. These companies flourished during the era of ZIRP, zero interest rate policy, following the 2008 financial crisis. When capital was essentially free and yields were low, venture capital funds poured billions into speculative pitch decks and flashy YouTube animations. Startups spent tens of millions of dollars building hyper-realistic 3D models, hosting lavish media keynotes, and hiring PR firms to pitch stories of imminent orbital vacations. Robert Bigelow spent over $350 million of his own real estate fortune pursuing inflatable space habitats before Bigelow Aerospace laid off its entire staff in 2020. Orbital Assembly eventually rebranded to Above Space Development, pivoting away from 400-guest orbital resorts toward modest industrial microgravity platforms. When global central banks rapidly hiked interest rates in 2022 to combat inflation, the era of cheap money evaporated. Investors shifted from funding science fiction fantasies to demanding real unit economics, certified hardware prototypes, and clear regulatory approval pathways. When pressed for actual engineering progress beyond CGI renders, space hotel startups had no operational products to show. The hype cycle died, leaving behind warehouses of unused plastic mock-ups and burnt investor capital. 4. 2 ironclad rules to protect your portfolio. Space exploration will continue to advance, driven by specialized research stations, public-private scientific partnerships, and targeted microgravity manufacturing. But the vision of 5-star orbital resorts with luxury amenities will remain firmly in the realm of science fiction for decades to come. As analytical investors evaluating emerging technologies, this crash offers 2 critical lessons. Rule 1. Marketing can temporarily inflate a company's valuation, but it can never overwrite the laws of physics and basic economics. If a startup's core investment thesis relies entirely on the assumption that a fundamental scientific miracle or a 99% cost reduction will occur in the near future, you are not investing. You are gambling in a casino. Rule 2. Beware the trap of premature scaling and presentation hype. The moment a young company dedicates more energy to cultivating an aura of massive success, staging high-end keynotes, releasing cinematic CGI renders, and constantly redesigning their corporate branding, instead of obsessively testing hardware and proving unit economics, you are looking at a business destined for failure. Thank you for watching all the way to the end. Subscribe to the Sanchez Invest channel, turn on your notifications so you never miss a new analytical breakdown, and leave a like on this video. It really helps the algorithm surface deep, data-driven content to an audience that values real insights. Now, I want to hear your thoughts in the comments below. Do you believe we will see an operational commercial space hotel before 2050? Or is this an insurmountable technological and financial dead end? Share your thoughts below. I'll see you in the next episode. Take it easy.